Hello guys. Today we are gonna stream our Leetcode contest number bi-weekly contest number 150. Welcome everyone to the stream. So I didn't check my mic was muted. So we'll go to the we'll go to the first question directly today. It's already late. So sum of good numbers. Sum of good numbers. Please. And sum of good numbers. Given an array of integers, nums, and an array k, an element nums of I is considered good if it is strictly greater than the element at indices I minus k and I plus k. If those indices exist, if neither of those indices exists, num I is still considered good. Return the sum of all good elements in the array. So there is an array which is called nums, and there's one more integer called k. Nums at index I is considered good if it is strictly greater than elements at element I minus k and I plus k. So first example 1 3 2 1 5 4 is the nums array, k is equal to 2. The good numbers are, okay, we'll check nums of 1, nums of 4 and nums of 5, and our output is sum of all the good numbers. So which is equal to 3, or else we'll take the second one. The second one, example, very simple example, nums is equal to 2 and 1, two elements in an array, k is equal to 1, output is 2 because only good number is nums of 0, which is 2 because it's strictly greater than nums of 1. Constraints given are the length of nums is less than 100 and greater than 2, greater than or equal to 2, which means that it's in the range 2 to 100 including both, and indexing of nums is from 1 to 1000 including both, and 1 is smaller than or equal to k is smaller than or equal to floor nums dot length by 2. So we'll go to our screen, writing screen. Yeah, bi-weekly 150. Chalo. So good number. First question, good number. Okay, good number. It's an array here. 2 1. Example I'm taking. It's the array and they are given k is equal to 1. Now there is no I minus k. I minus k is not there. We'll see at I plus k. I plus k, the number is 1. So 2 is strictly greater than 1, which means that the number at I equal to 0, the number at I is equal to 0 is good. And this is the only good number. Therefore, sum is equal to 2. Output will be 2. Our output will be 2. Or else we'll take one more array. We'll take it as 1, 4 and 2. We'll take k is equal to 1. So, now we'll take for 1. 1 it will fail because 4 is greater than 1 and 1 is not. Now I'll come for 4, which is at I is equal to 1. I is equal to 0. The number is 1. It's gone. I is equal to 4. I is equal to 1. The number is 4. Now, I minus k is 3. It is not existing. Sorry. I is 1 and 1 minus k is 1, which is equal to I0, that is 1, and 4 is strictly greater than 1, and at and next I plus k, which is 2. 1 plus 1 is equal to I of 2. The number there is 2, and 4 is strictly greater than 2. Therefore, 4 will be a good number. Now we'll check for I is equal to 2. I is equal to 2. What is the number there? 2. Okay, 2 minus 1 is equal to 1, which is I of 1. The number at I of 1 is 4. 4 is not greater than or equal to 2. Therefore, this fails. Fails. Therefore, the output will be returning is 0 first, there is nothing. 2 zeros and 1. The output will be 4. Now, what can be our intuition and approach to solve this question? I'll write first our intuition to write this question. Our intuition to write this question. Solve this question, I mean. Here we are required to find elements that are strictly greater than elements at I minus k and I plus k. Am I right? Yes. If they exist. In this condition, if they exist, if exists. If not, then it's all. If not, it's good. Only if exists. If not, it's already considered a good number. Now, we'll see. What we'll see? We'll go to the approach. Which approach we are gonna solve this question using? The approach. So the first one is very important thing. We'll iterate through the array. Iterate through the array. We'll iterate through the array. Here, we'll check for every index I and check if it qualifies for the good number. So how will we do it? So guys, how are we gonna do this? Iterate through the given array. Check good qualification. Mean check if it's a good number. In our second step, what we'll do is we'll check the conditions for good number. Check good qualification. In the first step, we are checking if it qualifies for good number. Second, we'll check conditions for good. What are the conditions for good? If I minus k exists, nums I greater than nums I minus k. Similarly, if I plus k exists, nums of I should be strictly greater than nums of I plus k. If either of this condition fails, if any fails, if any one fails also it's a fail, not good. Now that's all. In the third step, what we'll do is we'll calculate the sum. We'll sum the good numbers. If nums I satisfies condition, then we'll add it to sum. Add it to sum. And finally, we'll return final sum. This is a very easy question. Now we'll go to our question. We'll go to our code. Here is our code. So we'll add hash comments for better understanding. Here length of nums will get us the length of nums, length of array nums. I have created a variable by my name itself as Ranjan instead of sum here. It stores the sum of good numbers. Next, this first for loop iterating through the arrays. Iterate through the array. Next, assuming the next step is we are assuming current element is true. Assume current element is good. Next, we'll check if left neighbor, which is I minus k, is valid. If I minus k is valid, this is totally that. Here we are checking if it's equal, if it's like if it's following the good number condition, where it is like if nums of I is not greater, then we'll mark good as false, which means that it's not true. Now we'll go next. We'll check the right neighbor. If I plus k is valid, exactly as above, how we check for I minus. If it's not valid, we'll return false. And then finally, if good, if the number still remains good, this if case, if still the number is good, what we'll do? We'll add it to the sum. Ranjan here is giving us the sum, so we'll add it to the sum. Add it to sum. And then we'll return the sum. Here the variable used for sum is Ranjan, so we'll return Ranjan. And we'll run this code. It's accepted for the given test cases, and we'll submit it and check if it's accepted or not. So it's accepted and it beats 100% of the time. So now we'll go back to our writing screen. The time complexity and space complexity of this. The time complexity. What is the time complexity, right? Very easy. Okay guys, what is the time complexity? Very easy one. Iterating For iterating over the array once from 0 to n minus 1, it takes O of n, order of n. Next, for all the other operation, constant time comparisons, it takes O of 1. So, this comparison says I minus k and all those. I minus k, I plus k, those comparisons. I minus k, I plus k, those comparisons. So, this is going to take O of 1. So, the overall time complexity is going to be O of n. Now, we'll see what is the space complexity. Few integer variables we are using, n, and the other one is good. The other one is where for the space complexity, n, good, and Ranjan are used. So they get constant space which is O of 1, and no other data structure is used. So the space complexity of this will be equal to O of 1. Now, any doubts for anyone, guys? Or else we'll go to our next question. We'll go to our next question. Question number 2. Okay, guys, we'll go to the second question. Our second question, close this. Separate squares 1. Okay, you are given a 2D integer array squares. Each square I is equal to xi, yi, li represents the coordinates of the bottom left point and the side length of square to a parallel to the x-axis. Find the minimum y-coordinate value of a horizontal line such that the total area of the squares above the line equals the total area of the squares below the line. Answer within 10 power minus 5 of the actual answer will be accepted. Note, squares may overlap. Overlapping area should be counted multiple times. So what they have given is, there will be a square which is given, square of I is given as xi, yi, li, which means bottom left and side length, which is parallel to our x-axis. And they have given that the square might overlap and we have to give the sum. Like if it overlaps, it should be counted multiple times. We have to find the minimum y coordinate value such that the total area of squares above the line equals the total area of squares below the line. So if we draw a line here, above the square should be same as below the square. Here we can see the example, squares is equal to 0, 0, 1, 2, 2, 1. Two squares are there, 0, 0, 1 and 2, 2, 1. So if we draw a line at y is equal to 1, at that point, when we draw a horizontal line between y is equal to 1 and y is equal to 2, we'll have one unit above it and one square unit below it. So the lowest option for this is gonna be 1, and we'll return the output as 1.00000. So what are the constraints given? The length of squares is in the range of 1 to 5 into 10 power 4, including both. Square size equal to xi, comma yi, comma li. The length of squares I is equal to 3. Then xi and yi are in the range from 0 to 10 power 9, including both, and li is in the range 1 to 10 power 9, including both. Now we'll go to the intuition of this. What's the okay? Separate squares 1 will check the intuition. separate squares 1. So, what is our intuition, guys? Our intuition for this question will be we have to find a horizontal line. We have to find a horizontal line such that area of squares above equal to area of squares below. We have to just balance here basically. What we are doing here is we are basically balancing the horizontal line basically. Now, what we'll do here is the first point, each square will contribute certain amount of area. Each square contributes certain area above. Area above and below y coordinate, y-c-o-o-r-d, y coordinate. And the second point here is we'll have to create a function to find total area above line it will increase monotonically. It will increase so that what should we use here? Monotonic increase. We'll use binary search. Now, and the third point, what we'll do is instead of computing both above and below, instead of both above and below, we'll calculate below area below the line, calculate area below and compare it with half of total area. Now we'll go to the approach. What is our approach? It's a classic binary search question basically, that's all. We'll find the search range first. Find search range. Find search range. In that, what we'll do is compute. In computing, what are the three things we are going to compute? I'll write all the three of them. Minimum y, smallest y coordinate, oh my god, this is the smallest y coordinate among all squares. Next, what I'll do is max y. Max y. Largest. What is this max y? This is largest y plus L amongst all squares. Amongst all the squares. Next, what I'll do is I'll compute total area. Total area. Just a second, guys. Total area. Total area. Sum of all squares. Sum of all square areas. Sum of all square areas. So we'll compute these three things in the first step. After this, what we'll do is we'll go to our second step where we'll define the function in our case it's Ranjan. You can take it anything. In this, what we'll do is this function will create total area below the horizontal line, below y val, the horizontal line y value. Here, what are the cases we'll get? First one, if y val greater than y plus 1, the square is completely below. Square fully below. So what we'll do in this case? Add full area. Add full area. And in the second case, what is our second case? If y val smaller than y, square is completely above. Square fully above. So what we'll do? We'll add 0 because it's fully above, right? So we'll add 0. Now, the third condition is if y val, sorry guys, if y is the smallest or y is smaller than or equal to y val, which is smaller than or equal to y plus 1, the line cuts through the square. This means that line cuts the square. So here what we'll do is we'll add partial area. Okay, this is our second step. And here comes our main step of this whole code. In our third step, what we'll do is we'll use binary search. We'll use binary search to find correct value of correct y coordinate. Correct y coordinate. I'll just write it as y. It's pretty much explanatory. So yeah, we'll go how to find it. We'll see. First one, like how we'll normally do. Initialize low is equal to minimum of y plus, sorry, and high is equal to max of y. Then we'll perform binary search while there's a condition. While high minus low 10 raised to minus 5. This is ensuring our precision. Binary search ensuring precision. The number of digits after decimal point. After this, we'll compute mid, the classic binary search. Compute mid. Mean everyone knows how to do a binary search. Low plus high by 2. Low plus high. Low plus high by 2. Mid is equal to low plus high by 2. Now, if we have called the function, since I have called Ranjan as the function, I'll use the same here. If Ranjan mid is greater than or equal to total area by 2, move will move high is equal to mid, else will move low is equal to mid. So after this, what we'll do is we'll go to our final answer in our step 4. Final answer. Final answer. In our final answer, result is equal to low plus high divided by 2.2, 2.0. Okay, here since we want it in float, we'll use a 2.0. So now we'll go to our code. So here is our code. We'll add commands for better understanding, guys. So here is our code. They have given class solution and define separate squares. They have already given it in the solution itself. So now we'll first initialize min y, max y, all those things, and total area, right? Exactly like how it's written, min y, max y, and total area. And after that, we'll go for a for loop, which we are looping whole over the square. Now we'll create a function Ranjan with value as yval. This is to compute total area below a given horizontal line. To compute total area below a given horizontal line, and we'll initialize total area as 0. Next, for x, y, l in squares, we'll again iterate through the square. The first one, if y value is greater than y plus l, that is entire square is below, full square is below. And the next one, if y value is smaller than y, full square is, in this case, the full square is above. And in the third case, it is square is cut partially. Square is partially below. Square is cut and it is partially below. Now we'll return the total area. After this is for binary searching for correct y coordinate. Binary search for correct y coordinate. This is for correct y coordinate, and then high is equal to mid. This is all binary search, normal binary search. We are calculating the mid value with precision. This is mid value with precision. Binary search with precision. Now, just calculating the mid value after that. High is equal to mid means we'll move down. If low is equal to mid means we'll move up. And finally, our answer is low plus high divided by 2.0. 2.0. We'll run this code and check if it works. Oh, just a second, guys. I'll just copy this for further usage. Okay. I'll run this code. It works perfectly. I'll submit it and check if it works for the hidden test cases. And it works perfectly well for all the given test cases. So it's accepted and beats 100% of the users. So now we'll go for the time complexity and space complexity of this question. The time complexity. Binary search. Anyone in the chat, what is the time complexity of binary search? Anyone, what is the time complexity of binary search? So guys, what is the time complexity of binary search? For binary search, the time complexity is O of log n. And then for area calculation, area calculation, it is O of n. So what is the total time complexity? Time complexity is equal to O of n log n. And what about the space complexity? Okay, someone in the chat give an answer. O of log n is the correct time complexity for binary search. The space complexity, we are using very few variables like what do you say, high, low, mid, high. These things are used. And what else? Max y, min y. These are used, which will bring the time complexity to O of 1. Sorry, which will bring the space complexity to O of 1, and the total space complexity is equal to O of 1. With this, we'll wrap up this question and we'll go for a third question, which is separate squares 2. The third question, separate squares 2. So, what is the okay, I'll go to the question first. We'll read the question. The question here is you are given a 2D integer array squares. Each square is same as like those are similar to the previous question. Okay, is this exactly the same as the previous question? Okay, very similar to the last question. We have to find minimum y coordinate value of a horizontal line such that the total area covered by square above line equals to the total area covered by the line below the squares. And precision value is 10 power minus 5, again like 5 decimal values, like 5 values after the decimal point. The same example, everything is same they have given. Now we'll directly jump into the way how we can solve this. First we'll go to the intuition. Sorry, intuition. First intuition. Again same horizontal line that splits the horizontal line. Horizontal line that splits total area. That splits total area. Oh sure. That splits total area. Also they are given that squares might overlap. Squares overlapping is there. So there's a change in this question. The only change in this question, in the previous question, we calculated overlapping as many times as it's coming. But here we have to calculate the overlapping only once. So this is gonna be a major factor in a lot of questions, like lot of test cases. Here overlapping, and this overlapping should be considered once. Consider it once. Previously we considered it all the times it appears, but here we are considering it once. Now what is the approach we are going to follow for this? The approach. The approach for this question we are going to solve is, we'll make first one, we'll make a sweep line algorithm based on the events. We'll make a event based sweep line algorithm. What is a sweep based algorithm? Anyone? Anyone, what is a sweep based algorithm? Sweep line algorithm. A sweep line algorithm, it is used to process events in sorted order along one axis. It's either x or along y axis. It will maintain active set of intervals. It will use segmentary or ordered set. Okay. This is used for line segment intersections, rectangle unions, and geometric queries. So now, in our first step, what we'll do here is event based sweep line algorithm. Event based sweep line algorithm. Event based sweep line algorithm, what this will do, this will convert each square into two events, each square into two events. The first one, starting event, starting event at y is equal to yi, which will add coverage, adds coverage And second one, ending event, at ending event at y is equal to yi plus li. This will remove coverage. This will remove the coverage. Now, after this, what we'll do is we'll store unique x coordinates. Store unique x coordinates to track coverage changes. Coverage changes. And then second step. After this, what we'll do is, as we are using sweep line algorithm, we'll be using a segment tree. A segment tree for dynamic range updates. Dynamic range updates. The first step here is we'll maintain the segment tree. Maintain, I'll write it as segment segment tree, where each node will each node stores total width, total width covered width of covered x coordinates at different y levels. And secondly, after this, we'll use a cover array, track active elements. Use cover array to track active segments. Active segments. And after this, we'll update dynamically. We'll update the segment tree as sweep line moves. As sweep line moves, sweep line moves the dynamically update segment tree. Segment tree. And then we'll go to our third step. This is a very lengthy question actually, because we have to check, we have to make sure that only one time it is, like only one time the array is gonna, like only one time the square is counted. Now we'll compute the total covered area here. Compute total area, total covered area. What we'll do here is perform vertical sweep. Perform vertical sweep. and will update the segment tree and will accumulate the covered area. Now, not gonna explain the total steps in like, okay, I'll tell you in detail. Perform vertical sweep over y coordinates and update segment tree and accumulate covered areas. So, anyone in the chat, how we can proceed with this? I've solved this half. Anyone in the chat? Anyone in the chat? How? So guys, anyone how it can be done next? How we can proceed next, guys? How can we proceed, guys? Okay, I'll continue since there are no replies in the chat. The fourth step, we are gonna find the find splitting y coordinate. So for this, what I'll do is, this is our final step. After obtaining total area, total covered area, we'll find lowest y, find lowest y where the accumulated area is equal to half of total by 2. Now, if exact split occurs within a range, if split occurs within range, if split within range, what we'll do? We'll interpolate between two y values. Interpolate between two y values. Two. Okay, wait, guys. It's not 2 minus y, I said 2y. So no confusion, so I'll just remove 2y values. After this, we'll directly jump into a question like the code. It's a bit lengthy code, we'll add commands to understand it better. Okay, first one, define separate squares and class solution, both are given. Now, convert squares into events and extract unique. Convert the first one, event self.access is equal to self.ranjan squares. Convert square into event and extract unique x coordinates. X coordinates. Next, n is equal to length of x's. Then segment tree, we'll take the size of segment tree. Size of segment tree. We'll take n is equal to 4 into m as size of segment tree. Then we'll initialize segment tree and coverage array. Initialize segment tree and coverage array. Doesn't okay. The first one we are initializing the segment tree, and in the second one we are initializing the coverage array. So after this, we'll go half of the total area. We'll calculate the half of total area. Half of total area, and then we'll reset the segment tree for second iteration. Reset segment tree for second pass. After that, I'll return the y coordinate that splits the y coordinate that splits. That's all. Y coordinate that splits the area into two halves. Area into two halves. After that, I'll call a function by my name itself, Ranjan again. We'll take xs, which is unique x coordinates. Unique x coordinates and events. Events y type, in which it is like y comma type comma x start comma x end. After that, we'll process each square. Process each square. Then events dot append y comma 1 comma x plus 1, which is start of square. Start of square, and the next one is y plus 1 minus 1 x comma x plus 1 end of square. End of square. Next, I'll remove the duplicates and sort here. Remove duplicates and sort. We'll use events dot sorting sort O of n log n, O of n log n, yeah. It will use tim sort automatically. Then I'll return process the events and x coordinate. Return events and x coordinates that are process. Even return process. Okay, after that I'll have to use one more function, update tree. Now the first condition, out of range, out of range. If it's out of range, we can't, no update is needed. No update. Update tree if q1 is greater than n, or qr is smaller than nl. If ql is smaller than, sorry, if ql is greater than or equal to nr, or qr is smaller than or equal to nl, then we'll return out of, it's out of range, so there is no update needed, we'll return it. If ql is smaller than nl and qr is, sorry, qr is greater than or equal to nr, we'll update the coverage area, like we'll update the coverage count. Update coverage count, and after that we'll come to this if statement again. If self dot if ql is, here we have took if ql is smaller than or equal to nl and nr is smaller than or equal to qr. After that we'll come to the next if statement, which is self dot cover node is greater than 0. In this case we'll update segment tree based on coverage. Update segment tree based on coverage. This is segment tree, not okay, I'll write. Else no, this is for fully covered. Full covered. After this, else if single point, like not covered, single point not, will take nr minus nl is equal to 1. In that case, self dot segment node is equal to 0.0. Else we merge all the children values, merge children values of the segment tree using self dot segment node is equal to self dot seg node into 2 plus self dot seg node into 2 plus 1. Will merge all the children values. Next we will define one more function called sweep, where we'll initially keep total as total cover area, which is 0, total area covered, total covered area, and then current y level. We'll take one more CURY, current y level, current y level, and then I is equal to 0, initializing, we all know, then length of events. Then we'll run a while loop, delta y is equal to y minus current y, height of the horizontal line. This will give us height of horizontal slice. And after that, okay, shit, I said correctly but I typed it mistakenly. Delta y is equal to y dot y minus current y will give height of horizontal slice. Next we'll call total plus is equal, total is equal to, and like we are using shorthand, total plus that one, self dot segment 1 into delta y which will give me area of the slice, and then current y is equal to y, move to new y level. After this, guys, we'll run one more while loop to process all the events at y level. Process events at same y level. In that will After that we'll update the segment tree, here, and then we'll finally return the total covered area. Return total covered area, and then we'll initialize accumulated area as 0, like it's basic. Next, current y level, and then I is equal to 0, length of events. After that, current length is equal to self dot segment 1, which is current width at current level. Current width at current level, and then we'll take a if case. If exact split is within the segment, if exact split within segment, what we should do? We have to interpolate. Then we'll have to get the accumulated area, right? For that, we'll use current length into delta y, accumulated area, and then current y is equal to y, which is to, already we know, move to the next y level. I'm not gonna write that. Next, we'll use one more while loop. Here, finally, we'll update the segment tree. This is just for updating the segment tree. And then finally, we'll call the final function, define find index, where I'll use binary search. I'll write it in highlighted. Binary search to find index of value in sorted list ARR. Here, this current y is our final answer, guys. Like, not the, yeah, this is the, this will return us, not the final answer, it will return us the y level that splits the area, Now, what I'll do is, this is basically binary search. Everyone knows how to binary search works. We'll find the mid and then we'll just split it. Now, I'll just submit this code, and it, It works perfectly fine and it beats 100% of the time. Now I'll go for the time complexity and the space complexity of this question. The time complexity of this question, like this code, the given code which I have written. First, where all the time is used. Sorting events. I already said sorting events or order of n log n. Tim sort. Next, building segment tree. Building segment tree. O of n log n again. Next, sweeping through events. Sweeping through events. Sweeping through events. Sweeping through events. Again, O of n log n. So after that, what? Binary search. Binary search, we all know what is the time complexity. Binary search. O of log n, which will make our total, oh I'm sorry guys, which will make our total time complexity as O of n log n. And the space complexity here is for sorting events, x coordinate and segment tree, it's way O of n for sorting events, x coordinates and segment tree. So the total time complexity is, sorry, the total space complexity is order of n. Now, with this, we'll go to our final question, our fourth and the final question. Shortest matching substring. You are given a substring S and a pattern P where P contains exactly two star characters. Sorry. Just a second, guys. Okay. Shortest matching substring. You are given a string S and a pattern P where P contains exactly two asterisk characters. The asterisk in P matches any sequence of 0 or more characters. Return the length of shortest substring in S that matches P. If there is no such substring, return -1. A substring, we all know what a substring is. It's a contiguous sequence of character within a string. An empty substring is considered a valid. Now, they have given S for us, A, B, A, A, C, B, A, E, C, E, B, C, E, and P as B, A, asterisk, C, asterisk, C, E, and output they are given as 8. The shortest matching substring of P in S is B, A, E, C, E, B, C, E. Because in asterisk place we can add any number of characters they are given it, 0 or more characters. So, now if we go to the second one, S is equal to B A C C B A A D B C and P is equal to C C asterisk B A A asterisk A D B. There is no matching substring, so we are gonna return it as -1. So we got how it works. Now we'll just go to the constraints. The length of S is in the range of 1 to 10 power 5 including both, and then the length of P is from 2 to 10 power 5 including both. S contains only lowercase English alphabets and P contains only lowercase English letters and exactly 2 asterisks. So with this we can go to our question now. We'll go to our writing screen. I'm gonna explain this question a little fast, guys. We'll go for the question. Shortest matching substring. Give me a second, guys. Yeah. Intuition. Shortest. What was the question? Shortest matching substring. Matching. Now, firstly, intuition. Feel like this too big. I'll just reduce the size. Yeah. Intuition. We have to find shortest contiguous substring. Substring. No, this is very thin. The earlier was better, I guess. Substring in S that matches P, where P has 2 asterisks. Why is this size making an issue? Okay, I'll just reduce the size, let it be. Now, we have to include empty sequences. Empty sequences included. Empty sequences included. Now, after that, we can we have to observe that P can be split into 2 parts, 3 parts, A, B, and C, where asterisk is spectator. Now, we'll go for the approach. This is our intuition. We'll go for our approach. The first step, what we'll do, we'll pre-process pattern P. Pattern P. For this, what I'll do, I'll split it into 3 parts. Split P to 3 parts, A, B, C, where P is equal to A asterisk B asterisk C. These are not alphabets or letters. These are just 3 parts, A, B, and C. Don't confuse here. It's not like in example the ABC. Now, what we'll do is, after this, we'll compute the length. Compute length NA, NB, NC, mean the length of these 3 parts. And after this, what I'll do, we'll go for our second step, which is we'll compute longest prefix we'll compute longest prefix suffix. Compute longest prefix suffix, also known as LPS. What I'll use here? Anyone where there's an algorithm. How is LPS used? We'll use a very famous algorithm for string matching, used in string matching. Anyone, which is it? We'll be using KMP algorithm, which is known as Nutt, Morris and Pratt algorithm to compute the longest prefix. I'll just explain you the algorithm first, guys. We'll just algorithms. Okay, I'll go for this. Okay, fine. I'll delete it. Within this question, I'll explain you the algorithm. I'll go a bit away ahead, or I'll explain here itself. Here, KMP algorithm comes into action. KMP algorithm, which is Knut, Morris, Pratt algorithm. What does this? This will efficiently find occurrences in a pattern P and in a string S, and this will be pre-processing so that it will avoid redundant comparisons. Now what will happen here is the time complexity of this is gonna be like KMP is gonna be O of n plus m, but if we use brute force, oh, just a second. If we use brute force, it will be O of nm. So we'll be using KMP in computing longest prefix sum. We'll see how it's calculated now. Longest prefix sum. We'll use KMP, I said. Use KMP. Use KMP algo. Generate an LPS array. Generate LPS array. LPS, longest prefix suffix array. For each we'll use KMP to generate LPS array for each of A, B and C. For each A, B, C in S. Now for this what I'll do is I'll construct LPS A, LPS B, LPS C to find to find occurrences in A, B and C. Now we'll go to our next step, third step. We'll go to our third step, which is find starting indices of substring in S. Find starting indices find starting indices of substring substrings in S, which are the three substrings in S A, B, C. For here I'll again create a function with my own name. In the submission I have created with my own name. So yeah, I'll create function Ranjan, which will extract will create function Ranjan here, sorry guys. Next what we'll do, we'll call a function Ranjan which will extract indices where A, B, C appear in S. After this, we'll use binary search. I don't know why it was all binary search today. Use binary search, which is bisect left basically. Bisect left to efficiently locate, to locate, to efficiency locate, like basically to locate valid positions for B and C after A. Valid positions for B and C after A. After this, the next step, our fourth step, finding shortest matching substring. Find shortest matching substring. Now, what I'll do is iterate over over occurrences of A of A in S. After this, for each occurrence, for each occurrence, for each occurrence of A, nearest occurrence of B appears after A. Nearest of B, nearest occurrence of B that occurs, sorry, that appears after A. That appears after A. After A. Now exactly same for each occurrence of A, for each occurrence of B here now. B, Sorry. Yeah, for each occurrence of B, we'll find the nearest occurrence C, nearest of nearest occurrence of C that appears after B. Now after this, what I'll do is I'll compute substring length, substring length. How? K minus I plus NA, and after this, okay, K minus I plus NA, and update answer. After this, update answer with with minimum minimum found value. And in our final step, what we'll do is we'll return the result. Fifth and the final step, I'll return the result. Return result. Valid substring means valid substring. Valid substring found. Return it. Return valid substring. Else, if else, return -1. Else, return -1. Guys, we'll just okay, we'll go to the code. Here is our code, not much difficult. We'll import bisect left from bisect and math from we'll import bisect left from bisect and math from math. We'll import infinity inf. Class solution is given. Shortest matching substring function is given. Now what I'll do, first step, we'll define LPS, pre-compute LPS using KMP. Pre-process LPS using KMP algorithm, After that, this whole thing is using KMP algorithm, pre-processing it, and then I'll call a function Ranjan with my own name. What this function will do is find valid starting indices where a pattern occurs in S. Here, for I comma L, enumerate, we have used enumerate, we'll ignore the first n characters, the pattern part. Ignore first n characters, that is the pattern part. The pattern part. Now, if L is equal to n, which means that full match found, full match, will return and will store it midway. Store input midway in S. Store input midway in S. Now, what we'll do, we'll split the pattern wherever we find a asterisk. Split pattern into three parts. Into three parts based on our asterisks, and then calculate their length of three parts, and after that compute the LPS for pattern matching. Compute LPS for pattern matching. For pattern matching, and after that we'll get the valid indices here. Valid indices. Valid indices for each part. I explained it in step 4, I guess. And then we'll use a try condition. Firstly, to find the shortest valid substring using binary search. Find shortest valid substring using binary search. And the try condition itself is for that. And for I in indices A, I'll take j is equal to indices B, bisect left, indices B of I plus NB, length of B, NB. Find the next B after A. This is for finding next B after A. Next B after A. And this is for next C after B. Next C after B. And then I'll find the minimum answer. I'll compute the length of substring. Compute length of substring, and then except pass, will use a pass condition. Now, if we have to return -1, if answer is infinity, else we have to return the answer. This is final answer. -1 or valid substring. We'll return -1 or valid substring. Now I'll submit this code. And this code should work perfectly well, we'll see. And this works perfectly well and it beats 100% of users. Now, we'll analyze the time complexity with the help of Leetcode itself. It shows O of n. I mean, here it shows O of m, O of n, everything as O of n itself. And the space complexity is O of n. We'll see how it's O of m. It's not O of m actually. So guys, actually the answer shown by Leetcode here is wrong. The time complexity here is for splitting P. Splitting P, we use O of m, O of m. Then LPS computation, LPS will use order of n. Then finding indices, find indices O of n, total O of n. Now binary search. Binary search O of log n. Leetcode, maybe they just showed one dominant term, guys, which is, and in the worst case, the time complexity of this is gonna be, the time complexity at worst case is gonna be O of n log n. And the space complexity is pretty much simple. The space complexity here is for LPS arrays, order of n, then listing the index lists for A, B, C matches. For this also we'll use O of n, and finally the total space complexity is equal to order of n. With this, we are gonna end today's live stream. If anyone has any doubts, you can tell me in the text. You can put in the comments. Please like, share, like the video, like the live stream, like all the others. Watch them. Share the channel, share the video, increase the number of views. Subscribe to my YouTube channel for more such content. We'll be bringing all the contest reviews. Tomorrow's Leetcode contest also, like the weekly contest, is also gonna be there. The review will be coming by 10 itself. From 10 to 11:30, the stream will be there. So with this, we are gonna end today's live stream, guys. Thank you everyone for joining. Bye, guys.